So let's look at these formulas. So today is all about finding surface area and volume of some common shapes. We're going to start off by looking at just the basic formulae for area, and then we're going to have a short break probably after we've looked at some of those, and then we'll look at volumes and surface areas of three-dimensional objects, which is what the main thrust of today is about. So let's have a look at some of these formulae. Well, you've got, if you think about the most basic formulae, the area of a rectangle is length times width. It turns out that the area of a parallelogram is base times height. Here is the formula. Base times height, but it's perpendicular height. And so, h, in this particular case, is the perpendicular height. Yep. I'm just about to explain it. Perpendicular means at right angles to, or vertical. If we talk about the vertical, it's often called a perpendicular. So what's perpendicular to the horizontal? The vertical, at right angles. And this is a common abbreviation of perpendicular, little right angle symbol with an R for perpendicular. I tend to use that. So in other words, this height here is the vertical height or the perpendicular height, not the length of the side. So in other words, if we look at the side of the parallelogram, that's this here. We're not after that side, that's not the height. If I know this dimension here, then I'm actually after this. Now that's a right angle, so it's perpendicular to. So I'm after this. If I know this, call it C, and I know this, call it B, how do I find A? What's it involved with? Pythagoras. Pythagoras says that this two sides, short side squared, a squared plus b squared, equal the hypotenuse, or the long side squared. So if I want A, I have to rearrange this formula to find A. What do I do? What's the first thing to get rid of? Take away b squared, George. So a squared equals c squared minus b squared. I'm after a is squared, so what do I do? Square root. So a equals the square root of c squared minus b squared. So that formula is often used to find the perpendicular. In other words, this vertical A. Look at the trapezium formula underneath, look. That too involves h, which is the perpendicular height. So if I didn't know it, hopefully I'd have the means to find it out by using Pythagoras. If you look at the area of a circle, we should know that it's pi r squared. In this form, that's if you know the diameter. So if you don't want to bother about halving the diameter to get the radius, you could just plug the diameter directly into that formula. And you might want to prove for yourselves why that formula is the same as that one. I'll leave that as a little exercise for you. But a lot of people just remember that formula, pi d squared over 4. These other ones, these next two, are fairly self-explanatory, I hope. A semicircle is going to be half the area of the whole circle. Obvious, okay? Look at the sector of a circle. A sector, which is a sector, is something that's drawn from the centre of the circle. So two lines are drawn from the centre, and there you've got the sector. Angle theta is the angle of the sector. So if I divide theta by 360, because the whole circle is 360, I get that fraction of the whole circle. So in other words, theta over 360 is the fraction of the circle, pi r squared. So if theta was 90 degrees, that would be a quarter of the circle, wouldn't it? And 90 divided by 360 is a quarter. So that's where that formula comes from. And finally, we've got two formulae, one for the area and one for the perimeter of an ellipse, which is not a common thing to find, but there it is. Actually turns out to be quite a straightforward formula to use. If you know A and B, the area is just pi times A times B. What I want you to do is to have a go at some of the questions in the exercise that follows on from this.